Hello, my name is Ian Buckley and you are watching MakeUseOf.com. Today we're going to be looking at Mo.js, which is a motion animation library built for web use. This thing is a lot of fun and it's fantastic in that you don't have to be necessarily fantastic at code or art to make great looking things with it. And I am the perfect example of this. I am not an artist and I'm not particularly good at coding. However, today we're going to go through and learn some of the basics of this fairly new library and some of the things that it can do. For example, one of the example projects shows that it's very good for doing things with, say, dynamic lettering and things like that. However, today we are going to create from scratch a Mo.js sketch, which will make it so that wherever we click on the screen, we get lots of beautiful shapes and all these kind of things moving out. And as I said before, I have not particularly much of an artistic eye. I'm not all that good at coding, and yet this did not take me very long to put together, and I will show you how I did it. So we'll be using CodePen today. So open a new pen. It's free to start an account, and this is a great place to fiddle with things. So we don't have to do any HTML or CSS today. I am going to drop just a body and a background color into here just so that the whole thing is the same kind of dark. We're going to be working entirely with JavaScript today. Specifically, we'll be working with the Babel preprocessor. Now, I don't really know much about Babel. I'm not all that fantastic at JavaScript, really. But all the examples for Mo.js I've seen use Babel, and it seems to make things just a little simpler, especially if you're someone that doesn't really know much about coding, like myself. And we're going to need an external script for this, which is the Mo.js library. Now, you can see that I've actually had it here recently, but if you want to search for it, you just type Mo.js into this box, and it should come up just with the library here. So once you've clicked that, and you click Save and Close, we're ready to get started. So let's make a basic shape using Mo.js. So you call these as constants. I'm going to make a red circle, so let's call it red circ. And the way you do everything in Mo.js is you call a new Mo.js.something. So in this case, we're going to call a shape. And we're going to open a set of brackets to put our properties inside. And that circle now already exists with the default values of Mo.js. You just can't see it because things that aren't being animated don't show on the screen unless you tell them to. So right off the bat, let's just say is show start is true, which means that it will show as soon as it is here, and there we are. It exists. Now, the animation that I showed you at the very beginning that we're going to create starts with when you click a point on the screen, a red circle appears and then widens out and disappears. So to do this, let's take the circle we already have and give it a stroke in red. And as you can see, it's already updated itself, and you can see it has a red stroke, but it's not very easy to see because of the pink fill that is natural with this circle. It's just the default value. So let's change that by saying we want no fill. And already we're starting to get something that looks a little bit more custom and how we want it to. We can change a couple more of these values. Let's say we want the radius to be smaller because it's a little bit too big right now. And let's say we want the stroke width to be a little bit wider because it's a little bit too thin for us right now. And already we're going to have something. I have an error. No, I don't. Already we have something which looks like the default state of this thing. Now, I don't know if you can remember from the part we showed before, but this thing, it's the very first thing that happens, and these edges fade away. So how could we do this? Well, one of the ways we could is by animating one of the things, that one of its properties. So let's start by actually, just so you can see how it works, animating the opacity. So as well as these having values, you can also make these deltas. So instead of it just being the opacity is 1 or 0, I'm going to have it so the opacity starts at 1, and then with a colon denotes that it goes to 0. Now, right now, this isn't going to do anything because we haven't given it a duration in which to do it. So if I give it a duration and say I would like this to take 2,000 milliseconds to do this, now it has all of the information it needs in order to animate itself, disappearing. But it isn't going to work because there's nothing playing the animation. So this is what I was talking about before with isShowStart. This is good for just seeing a shape if you just want to see it, but let's take that out now. Let's comment that out of our code. And instead, under here at the very bottom of the brackets, we'll call the play function. which means whenever this page is loaded, we have our circle, and it changes its opacity from 1 to 0 over 2 seconds. And every time you refresh the page, it will play it once again. But what if we wanted it to wait for a while before it faded out? Or what if we wanted to make it fade out in a more interesting way? Well, what we'll do is we'll remove this play function for now. It was useful to see what we were doing, but we're going to do something else with it now. So we don't want it to fade out in this point now. All we want it to do for now is appear, stay for a duration, and then we want it to do something else. And we do that using the then function, which gives us a whole new set of brackets in which we can put our new things. So what I'd like it to do, rather than just fade out, I'd quite like it to change its stroke width to 0 and then scale itself out. So I'm going to do that by calling the scale function. And this is something I found in the Mo.js tutorials. I didn't actually realize it was possible to call just scale to 2, so it'll take whatever scale it already has and just scale to it. And the other thing is, in these deltas, you can use easing. The Mo.js library has a whole load of different easing methods you can use, and it just makes things look a little bit better. If you have something just going straight from A to B, it kind of looks a little bit unnatural, and humans aren't really used to seeing that, but easing is what makes things look nice. Easing is what makes motion graphics pop and work. So now that we have this, let's look at it. Well, we can look at it exactly the same way as we did before by calling play here instead. And now, you see, I'm very glad that it asked me this. I keep forgetting to click save, and it causes problems. So now, when I reload, we should have a circle, and then after 200 milliseconds, it disappears out like that. So now, we're starting to get something that looks a little bit more reactive, which is nice. This is the kind of thing that we want. Now, it's sticking around for way too long for now, but you can imagine that if we drop the duration here to something like 150, so it appeared, and then mostly it was just disappearing like a click, there we go. Yeah, that's exactly what we want. So if you were to imagine, I've got that again, if you were to imagine this was a user click, that seems like the perfect amount of time for a click. And so that's one of the things you can do with shapes, but this is just the very basic functionality of Mo.js. Things get really interesting when you start using bursts, so let's get onto that now. Now, calling a burst into life, into existence, is very similar to calling a shape into existence. So we're going to make some sparks. So let's say sparks equals new Mo.js burst this time, and once again, get with the brackets. So this thing, much like before, it does already exist. If you put a play function under it, you will see, yes, those 5 little things firing out. But the way bursts work is they are a collection of shapes being bursted out from a central point. So we don't need to actually tell the burst itself to do too much. What we want to do is talk to its children. However, saying that, let's set up this so it has a radius. I don't want the radius on this to be huge because it's going to be like a mouse click. So let's say 0 to 50, and I want a comma, and I've forgotten a colon. I'm great at coding. And I think that's all we sort of want. I mean, let's maybe have this one spinning. So let's give it an angle. I don't want it to spin particularly far. Let's say between 0 and 90 degrees. And then, yes, okay, you saw just then, if I save it and refresh it again, you'll see now it's got a slightly different radius, and they're spinning as they come out, but there's still not a huge amount happening. And so these pink things that you're seeing are actually the children of this burst. And if you want to change those, you need to speak directly to the children. So you do this within the burst, again, children, colon, open some brackets, and this is where we can start to change things. So let's say we want the shape of these children to be crosses. We can call that again. And if there are going to be crosses, we want it to have, I don't know how many points do we want the crosses to have. Let's say we want these crosses to have 15 points. And let's say we want them to have a stroke, which is white. And let's just see how that's going to look. There we go. Okay, so they're a little bit small. We can't really see them at this stage, but that's fine. We want them to be quite small. Because, again, this is all going to be reactive stuff for when the mouse gets clicked. All the bigger stuff we're going to make a little bit later. So once again, let's say we don't want it to have a fill, and we don't really need it to have any kind of an angle, and let's say we want its duration to last just 300 milliseconds, like I said up here before. No, I didn't. That's fine. Now, whenever this doesn't work, you'll notice sometimes, this will definitely happen to you unless you really know what you're doing with the coding side of it already. I save it and nothing is happening, and it's simply because it's very easy to forget these commas. And if you do, and then save it, it should work. And now we have something that's very subtle, very quick. If I get rid of the play function for the shape so we can see it a little bit better, you'll see that what we have is just a little burst. And I think that looks quite nice. Although what I would like is if there was a lot more of them. So what you can do is just before, inside the burst, so before you're in the children brackets, you can say how many of them you would like. So let's say 30 of them and see what that looks like. There we go. That's nice. That's a nice big moving out, yes, from the mouse point. And then once again, let's just stick a play function on here so we can see both of them together, the red circle and the white circle moving out. Great. That's a very nice reactive thing. But so far, we have to refresh the page every time we want this to happen. And ultimately, we want this so wherever the mouse is clicked is where this happens. So let's set that up now. So in order to make this reactive, we want to set up an event listener. This event listener will listen for mouse clicks anywhere in the document, and it will give the XY coordinates of that click to our sparks and our red circle and say, hey, do what you do and do it here. So I'm going to make myself just a little area here, just so it's slightly out of the way. And this is complaining because it needs that, yes. So this is the document event listener. Every time there is a click, it will carry out the functions in here with parameters. And we know we have the red circle shape, so let's add that. And what we would like to do is set it going by using the tune function. Now, this basically means it's going to go now, but what do we want to tell it? Is there anything we want it to know? And there is something we want it to know. We want it to know the X and Y coordinates of the mouse. So we give it its X coordinate by saying E page X. I believe that's the right syntax. Yes. And again, the Y coordinates by saying E dot page Y. And I believe that's all the information it should need in order to click. Yes, in order to come where the mouse is clicked. And again, we already called in play up there. We're not going to call play here. We're going to call replay. It's a subtle difference. It just means that every time the mouse is clicked, it will replay it from the very start of the block of code. So now, if we take this play function away from here and save it and click the mouse, we should start getting it. But you might be noticing it's all the way down here. Now that's because Mo.js, as standard, one of its standard values is put it in the middle of the screen. Which is why, when we just said is show start at the start, it showed us this circle in the very middle of the page. There's a very easy way to fix this. All we need to do is give the red circle some different default values. So we know that we want it to always show up at 0, 0. It's just that 0, 0 plus the mouse position is going to be exactly where the mouse is clicked. And we do that just by saying we want left to be 0 and we want top to be 0, which means that if this was called without any other positioning, it would be right up in the top corner here, but that's not what's going to happen. What's going to happen is going to be 0, 0 plus the mouse position, and there we go. We have a nice click. It looks like it is exactly where we want it to be, and the way we get sparks there is exactly the same way. Let's remove this play method. Let's get sparks and add this to the event listener. We want it to have exactly the same properties. Let's add those, click save, and now we should have the very beginnings of a very nice looking piece of, oh, I forgot the same thing, didn't I? Well, I've just showed you how to fix that. I'll fix that, and let's move on to making something a little bit more interesting. Now that our event listener is in, we can start adding plenty more things, anything else we want, really. This is the great thing. We've basically learned everything we need to in order to make really cool looking animations. We could just stop here and have a really nice click animation, but we could equally add to it. I mean, I saw those sparks. I thought those sparks were cool, so I decided let's make some more sparks. This time let's make red sparks. So this is the block of code I decided to do. As before, we set left to 0 and top to 0, which means that this is what gets added to our mouse position, and it means that it'll be in the position the mouse is clicked every time. It's a burst, and we want it to be 8 children. I want it to go from a radius of 150 to 350, so it's out the way of the one that we already have. And I decided it would be nice to have it spinning just a little, so an angle from 0 to 90 and easing with a cubic easing. So this time I chose lines for the children, which start red and end up transparent. They have a stroke width of 5, and the X scale, or just the scale of the lines, goes from 0.5 to 0 over time. And now we're going to put a bit of randomness in it this time. So there's a shift in degrees each time it's fired out, which is the angle from burst center it gets fired out from. And we've given it some random factors this time. We've also said the radius itself is going to be a little bit random. And again, the delay, which means that they'll all fire off at slightly different times. So this is the same as the burst we've made before, pretty much. We've introduced the idea of randomness, but it gets called the same way in the event listener with one extra change. So I'd already added this in just so I can uncomment it to be quicker. So we launch it the same way, we give it the mouse values, we want it to replay just as before, we want it to play from the start every single time. I've also included the generate function, and that means that every time that this gets called, it will generate new random values, so that when we do click, it will get a different value each time. And I like the fact that it's very random. It does actually mean that because of the random values, sometimes they encroach on the ones that we already have, but this doesn't particularly bother me all that much. I quite like the level of craziness that it brings to it. And so now that we have this, this is just a playground. You can just continue on as you want. So in the demo that I showed you before, the next thing that happened is that we had some triangles that came flying out, and they stayed on the screen for much longer. Again, this is a burst. We've done this before. This time the radius is massive. I want it to go all the way out. And again, we have cubic easing. So it's going from 0 to 1000. I want the angle to be spinning a lot. So I've said 1080. So that's how much it will spin with a quadratic easing. And I've even got notes for myself here, actually. Start 360 to show spin 1080 for effect. Well, let's do it. I'm not going to argue with it. So for now, it's going to go from 360 to 0 with easing. Again, 0 left and top. We want it to go exactly where the mouse clicks. I want 20 triangles, and this again in the children is where I decided I want them to be triangles. Now it is worth noting that you don't write triangle or pentagon or hexagon, you just write polygon and then say how many points it should have. 3-pointed polygon is a triangle, 5-pointed is a pentagon, etc. The children themselves can have their own spin. They can also spin independently of the burst. However, one thing I noticed while making this demo is when you trigger it from an event listener, the angle in the children does not get triggered. So I'm just going to comment that out for now because it's something that doesn't belong in this tutorial. Maybe in future we can look into different ways of using the children's own angles and all this kind of stuff, adding them to timelines and things like that. But for today, we're going to stick with the event listener. The radius of these triangles will go from 10 to 100, although I believe this works backwards, so they start at 100 and actually get smaller until they get to 10. And I've given them an array of colors this time. So I've said red, yellow, blue, and green. The way this works is we have 20 children, so the first 4 will go red, yellow, blue, green, and then 5, 6, 7, 8 will be red, yellow, blue, green, and it just keeps going through them all until they're all populated. And I want all of this to happen within 3000 milliseconds. I think several times I've said 3 seconds when talking about this during this demo. That's wrong. These are milliseconds, and I should have thought about that a little earlier in the tutorial. However, I'm sure you got the idea. Now, to call this, you call it exactly the same way as you have everything else so far. So we head into our event listener. We post it in. The burst is called triangles. We want to set it off exactly the same way as all the others. There's no randomness in this one, so I didn't bother setting it to generate. And now if we save it, we should get triangles coming out from every single place we click the mouse. And as nice as that looks, we'll just leave them at 360. I really enjoy it when you crank up that angle value quite a bit more. When this is at 1080, you get a crazy kind of carousel effect of it just flying around at such a speed that the colors all mold together, and that to me looks pretty cool. And so I'll grab the other things that I had set up for this demo and I'll put them in and talk you through them very quickly. But I'm hoping that by this point you're beginning to realize that even if you don't know a huge amount about coding, and even if you're not much of an artist, this is incredibly powerful. I am not very good at reading libraries and how to use them, and all of this stuff is documented both on the Mo.js website and also in their GitHub repository. And yes, just by using this, you can grab things and make beautiful things. So continuing on from our triangles, I'm going to add in the next layer of things you saw at that demo at the beginning, which were pentagons. So once again, I've got a constant shape. I've called it pentagons this time. It is a burst, and I've given it a radius starting from 0 to 1000, just like the triangles above. In fact, the way I made this one is by just copying and pasting the triangles and just changing some of the values. So this time round, I wanted it to spin in a different direction. So instead of going from 1080 to 0, I've decided to go from 0 to 720, but with the same easing. And once again, the familiar left and top 0, I want them to be 20 of them. This time, I changed the polygons points to 5, making them pentagons, and the radius of them to go from 1 to 300. Again, I think it actually goes the opposite way. It starts at 300 and ends at 1. And I gave them a whole different set of colors. Now, one thing here is I wanted it to happen after the triangles had already fired out. So as well as the duration of 3000 milliseconds, I added a delay of 500 milliseconds. And again, this delay will just delay at the start of everything that you do. Before any of this happens, the delay is counted out. So just as before, we can add this to our event listener. I'm going to use the triangles one and just replace the word triangles with pentagon. Is it pentagon or pentagons? Pentagons. Click save. And once again, we're starting to get some fairly psychedelic things happening here. And so I'll just grab the final piece of code in order to finish this off. And then we can look at what we've made and talk over what other things you can actually do with this. So before we finish here, there was just two more things I wanted to show you. The Stagger method is one of them. I created another burst here called just lines. Not a very imaginative title, I know. So this should all be relatively familiar to you right now. It is a burst. The radius goes from 0 to 1000, and the angle starts at 0, ends at 1440. So this one spins a lot. They both have easing. And left 0, top 0, so it happens at the mouse click. We want there to be 50 children, and we want these children to be lines. Now, once again, the radius of these lines is going to change over time with easing. We don't want a fill. We want the stroke to choose between red and orange, and this is where it gets interesting. The delay, instead of it just being delayed and then it does all of it at once, the stagger delay means every 10 milliseconds it will fire this off once. So every 10 milliseconds, everything we've asked for will happen. So if I go down to where we have the lines set up, we don't need red squares yet. Lines set up, we call it exactly the same way with the tune and replay inside our event listener method. And if I click on it, you'll see that those lines all fired off around, kind of like a Catherine wheel sort of situation. And that is the stagger. So if I just for a moment decided to take that stagger out, I'll show you how different that would look. So I'll comment out the stagger, save, and they all just fire off at once, and which also looks pretty cool. But I quite like having the stagger in, and I also thought it was a good way of showing it off. And there's just one more thing to go through before we finish this tutorial, and then talk about some of the possible use cases for Mo.js. The last thing I added here was a thing called red squares. And I just wanted to see what it would look like having scaling squares move with each other and across each other, making geometric patterns, and it actually looks really nice. So I'll just blast through this. We've done this several times already, this tutorial. We know to set up what size radius we want, whether we want easing or not. We know to set up the rotation of the burst and give it the right position for the click, the count. And in the children, I just said, okay, I want rectangles. And a rect is just a square by default. I wanted just the x-axis to scale up from 1 to 1000, for the y-axis to stay the same. No fill, red stroke changing to orange over time, and the width of the stroke changing from 5 to 15. The reason it's delayed is so it happens after everything else that's already happened, and it takes the same amount of time as everything else. And once again, in our event listener, we add it exactly the same way with the tune, with the replay. It's got no randomness, so we don't need to generate it. And once we've saved it, we get some pretty beautiful looking geometric patterns. And this only goes so, this just really outlines to me how very easy it is to make beautiful things with very little knowledge, because I didn't know that this was going to look like this. This was me messing around, and it looks absolutely wonderful. So there's just a couple of quick things I want to point out before we finish here for the day, and then you can go off and play with Mo.js and make me look very silly by making much more beautiful things. One final thing before we finish here, it would be remiss of me not to mention that there is a far more efficient way of holding values you're going to use over and over again. Now, I used quite a handful of different things here just because I wanted to show off different things it can do, but they all have some things in common. They all have an angle they rotate around. They all move out in a circular fashion. Let's say we wanted to do something very simple, like have lots of circles that had similar properties. Well, what we can do is create an object with those properties in. So I'm just going to create a circle demo property, and it's just going to have normal curly braces. It doesn't need the rest. It basically turns it into an object. And we're going to say, okay, your radius as a standard is going to be 25. And your fill as a standard is going to be blue. And you're going to have a stroke, which is going to be black. And I forgot this comma. And let's say a stroke width of 5. I believe that needs to be camel cased. So we have some properties here. To use them, we can just create another Mo.js shape, like we did so many times before. So I'm just going to create this thing called demo circ, because I'm full of very imaginative names. And as we did at the very start of this tutorial, let's say is show at the start, so that we can have our familiar pink circle right here. Oh, hello. Whoops. Okay, yes, thank you. Now, to take on the values that we've just created, we just type 3 dots and the name of the object. And it will take on the properties from this demo object, which is very, very powerful. Because what if you wanted to do hundreds of these? Rather than having to put those things out every single time, you get them, they appear, and you can just say, for example, I want this to be 25% to the left, and it should work. Although it's not, because I have an error somewhere, I'm not sure. Duplicate name, yes, of course, I understand. And so, now we have 2 circles. Now, what if we didn't want this circle to be the same size as the other one, or the same fill color? That's fine. As long as it's after this 3-dot circle demo, you can open it up and say, I want this one to be purple instead, and it will override the object that you've just created. Now, if you're already a programmer, you know this stuff already. That probably doesn't mean anything special to you. If you're someone who's just using this to try and make some cool art, if you can have like 50 of these similar circles with very slightly different values, you could make some beautiful looking things very, very quickly. And so I just wanted to show that off before we finished. There is so much more I could show you about Mo.js, even though it is very new, and even though I don't really know much of JavaScript, it's just so easy to get to use. Hopefully I'll be able to do more on this in the future. But if any of this was a little too fast for you on the video, if any of it didn't make any sense, head to the MakeUseOf website. There's a full article there going through everything we have done today. And don't forget to subscribe to this YouTube channel for weekly tech tips and giveaway. Thanks very much, folks. Bye-bye.